At AIPod, we aim to develop an AI-based risk score for patients with obesity, integrating wearables data, lifestyle information, imaging biomarkers, and clinical information. Early observations of the study show that integrating all those different data streams at the same time is actually feasible, and they form the perfect ground for an AI-based tool, which is made for personalized risk prediction. This can ultimately support more targeted therapy and provide time for individual patient care, which ultimately is crucial for understanding a patient's individual journey.
We have a lot of variability in the data because the data is coming from various centers, which is a challenge, but at the same time it's also a big plus of the project because it allows us to develop models that are in the end robust in the real world, because also the data is coming from the real world. On one hand, we developed segmentation models plus feature extraction pipelines, basically. The idea is to take a cardiac CT image, segment it into its substructures, and then extract different types of features, and then in the end use these features for clinical risk prediction. On the other hand, we have anomaly detection models. The idea is that you train a model on a healthy cohort, and this model learns the healthy variability of this cohort. And then during inference, you can use this model to detect all types of deviations from this normal variability. And this is a really nice approach because you're not biased towards specific labels of diseased patients that you've put into your training data, but you can see it more as an unbiased approach. And the third type of models that we have developed so far, the third category, there is the idea to take multiple modalities into account because this makes the model stronger. So far, we have combined text with imaging data, and there is more to come. There is the continuously acquired data, so the lifestyle data, and that will be a nice challenge that we have to tackle in the last year of the project.
What it takes for AI-based tools to be accepted in the clinical routine is that they need to be transparent and well integrated into already existing workflows.
So first of all, it's important to consider basic things like conducting a patient-wise split, meaning that you train on one cohort and evaluate and test on others. On the other hand, when you're doing this, you should also consider that we have multiple sites available, which is a big plus. Our plan is to train on one side and evaluate on others to also be able to evaluate the ability of models to generalize across centers, which is very important if you want to deploy the developed models in clinical practice. And last but not least, it's also important to not just evaluate your models against some values that you have available in your dataset and baseline them, so to say, against other AI models, but it's also important to check if these models actually improve the cardiac risk prediction compared to what's already available or what's already conducted in the clinical day-to-day practice.
And what we always have to keep in mind is that AI is not here to replace the human perspective in medicine, but it should rather support clinicians and enhance their efficiency in analyzing such complex data.